Hello students, in today's lecture we will discuss the examples on fundamental indeterminate form 0 by 0. What are fundamental forms, indeterminate forms? Among that what is fundamental form we have discussed in the last lecture. Okay, and what is the method to solve that fundamental form? That is L-Hospital rule. That is also the condition, and what is L-Hospital rule we have discussed in our previous lecture. So that we are applying here to solve the examples of fundamental indeterminate form 0 by 0. Is that clear? So, dear students, please subscribe the YouTube channel if you are not subscribed yet, so that you will get the update time to time. So let us see for first example, evaluate limit x tends to 0 x cos x minus sin x upon x square sin x. Is that clear? So let us see the solution. So what is given here? What is given? Limit x tends to 0 x cos x minus sin x upon x square sin x. If we put x is equal to 0 here, so this is 0 by 0 form. It is fundamental indeterminate form. Is that clear? So further we can evaluate this limit. Limit x tends to 0 x cos x minus sin x upon x cube into sin x upon x. We can remove this sin x by dividing by x. So if we, since we divide sin x by x, we multiplied x square by x. So what is the limit of sin x by x? Limit of sin x by x as x tends to 0 is equal to 1. We have studied in 12th standard. Is that clear? So if we apply this, so this will become limit x tends to 0 x cos x minus sin x upon x cube. Okay, so again this is 0 by 0 form. Okay, and therefore by L-Hospital rule, limit of f of x upon g of x as x tends to 0 is equal to limit of f dash of x upon g dash of x as x tends to 0, provided limit of denominator not equal to 0. Is that clear? So by this given limit will now become that limit x tends to 0. So first we find out f dash of x. So x cos x derivative is what? Minus x into sin x plus cos x into derivative of x is 1 minus sin x derivative is cos x divided by x cube, that is 3x square. This cos x minus cos x get cancelled. Okay, and so it is equal to limit x tends to 0 minus x sin x upon 3x square. फिर से चेक करो इसका फॉर्म क्या है था. Again it is 0 by 0 form. Is that clear? And so therefore again we can apply L-Hospital rule. Okay, means what? Limit of f dash upon g dash, okay, is equal to limit of f double dash upon g double dash, provided the limit of denominator does not equal to 0. So this implies that limit x tends to 0. Okay, so now what is the f dash? Look at here. What is there? Minus x sin x derivative is what? Minus x cos x minus sin x, minus x cos x minus sin x into derivative of x is 1. Is that clear? Upon 3x square derivative 6x. So again this is 0 by 0 form, and hence by Yale Hospital rule we will get limit x tends to 0, limit derivative of numerator, that is minus x into cos x, derivative is minus sin x, minus cos x into derivative of x is 1, minus sin x, that is minus cos x, and this is divided by 6x. So this implies limit x tends to 0, x sin x minus 2 cos x divided by 6. And here you can apply, if we put 0, to it is x, पहली term 0, minus 2 into cos 0 1 divided by 6. So limit exists, okay, as denominator not equal to 0, okay, and therefore it is equal to कितना आएगा 0 minus 2 upon 6, and that is minus 2 by 6, and that is equal to minus 1 by 3, that is answer, and hence given limit is minus 1 by 3. Is that clear? So this is the first example. Now let us discuss the second example, example 2. Okay, same method. पहले limit, first we check the form, and once it is indeterminate form, fundamentally indeterminate form, you can apply your hospital rule. So let us see given limit. What is given limit? Limit x tends to 0 tan x minus x upon x square into tan x. Okay, it is 0 by 0. So try to evaluate this. That is limit x tends to 0 sin x by cos x is the value of tan x minus x upon x square into sin x by cos x, and take LCM and solve this. So this will become limit x tends to 0 sin x minus x cos x upon cos x, and this whole divided by x square sin x upon cos x. This cos x will get cancelled, and so it is equal to limit x tends to 0 sin x minus x cos x, and this is divided by x square sin x. So this is equal to minus limit x tends to 0 x cos x minus sin x upon x cube into sin x by x, as in previous example, and its limit is 1. Okay, and therefore it is equal to what? Minus limit x cos x minus sin x, this is divided by x cube, because this limit is 1. Limit of sin x by x as x tends to 0 is equal to 1. Is that clear? So now this is 0 by 0 form, 0 by 0 form, and therefore by Yale Hospital rule. Okay, so it is equal to minus limit x tends to 0, limit x tends to 0, derivative of numerator x cos x, that is minus x into sin x plus cos x into derivative of x is 1 minus cos x upon 3x square. Okay, you look, cos x minus cos x get cancelled. So here is what? Minus x sin x and minus sin, that is plus x sin x upon 3x square. So it is equal to limit x tends to 0 x sin x upon what is the 3x square. 3x square. Is that clear? So did you understand this? Okay. So now this is 0 by 0 form. So therefore by Yale Hospital rule. This implies limit x tends to 0, limit derivative of numerator, that is x cos x plus sin x into derivative of x1 divided by 3x square का derivative, denominator का derivative 6x. Is that clear? Again it is, if we put x is equal to 0, this is 0 and this is also 0. So it is 0 by 0 form. So again by L'Hospital rule. So you will get limit x tends to 0, x cos x derivative is minus x sin x plus cos x into derivative of x is 1 plus sin x derivative is cos x divided by 6x derivative is 6. Okay, so this is equal to limit x tends to 0 minus x sin x plus 2 cos x divided by 6. Now check. If we put limit, so it is equal to 0 plus 2 into 1 divided by 6 means limit exists. Okay, and so it is equal to 2 by 6 and that is equal to 1 by 3 is the answer. So given answer is 1 by 3. Given limit is equal to 1 by 3. So similar kind of example here. Example number 3. Evaluate limit x tends to 0 e to the power x minus e to the power sin x upon x sin x. Is that clear? So let us start. So what we have? Limit x tends to 0 e to the power x minus e to the power sin x upon x minus sin x. Is that clear? Now check the form. This is 0 by 0 form. बराबर है, e to the power 0 is 1 minus e to the power sin 0, that is e to the power 0 is 1, 1 minus 1 0, and here is 0 minus 0, that is 0 by 0 form. Okay, and therefore by L'Hospital rule. Okay, so you will get limit x tends to 0 e to the derivative of numerator, derivative of e to the power x is e to the power x minus derivative of e to the power sin x is e to the power sin x into derivative of sin x is cos x. Okay, divided by derivative of x is 1 minus derivative of sin x is cos x. Again you check here, e to the power 0 minus e to the power 0 cos 0 upon 1 minus cos 0. So it is 1 minus 1 upon 1 minus 1, that is 0 by 0. So this form is 0 by 0. Is that clear? So therefore again by L'Hospital rule. So what you will get? Limit x tends to 0, derivative of numerator e to the power x ka derivative e to the power x minus, is that clear? Derivative of e to the power sin x into cos x. Is that clear? So what we have? Minus e to the power sin x into derivative of cos x minus sin x, बराबर है, minus cos x into derivative of e to the power sin x e to the power sin x into cos x divided by 1 minus sin x, cos x derivative is minus sin x. Okay, so this implies limit x tends to 0 e to the power x minus plus e to the power sin x into sin x minus e to the power sin x into cos square x, and this is divided by minus plus sin x. Now check here, for e to the power 0 is 1, e to the power sin 0, this is 1, sorry, 0, 1 plus 0 minus 1 divided by 0. So it is equal to 0 by 0 form. Okay, so again by L'Hospital rule, to given limit equal to limit x tends to 0. Is that clear? अब चेक करते हैं. न्यूमरेटर ई टू द पावर एक्स का डेरिवेटिव ई टू द पावर एक्स, यहाँ पे प्रोडक्ट रूल यूज करेंगे, यहाँ पे भी प्रोडक्ट रूल यूज करेंगे। तो ई टू द पावर एक्स का डेरिवेटिव ई टू द पावर एक्स, बराबर है। देन व्हाट, प्लस ई टू द पावर एक्स इंटू साइन एक्स, सो प्लस e to the power x into derivative of sin x cos x plus sin x into derivative of e to the power x e to the power x. Then what? Minus cos square x into e to the power sin x minus cos square x into e to the power sin x into sin x derivative cos x. Okay, then minus e to the power sin x into derivative of cos square x is 2 cos x into minus sin x, and divided by whole divided by derivative of sin x is cos x. Is that clear? अब हम चेक करते हैं कि व्हाट इज द कंडीशन. नाउ लेट अस चेक हियर, इफ x is equal to 0, denominator not equal to 0, and so limit exists. So we can therefore directly apply limit. Is that clear? So this implies that e to the power 0 plus e to the power 0 into 1 plus sin 0 0 minus cos 0 1 into e to the power 0 minus sin x is there, so 0, and this is divided by 1. So it is equal to, look at here, it is equal to 1 plus 1 minus 1 divided by 1. 1 minus 1 get cancelled, so this answer is 1. So this is the answer, and hence given limit answer is 1. So did you understand? So if you understand the lecture, please subscribe the YouTube channel Maths Clinic Counseling Center, and follow us on Facebook, Instagram, LinkedIn, Tumblr, and Telegram. Thank you so much.